Hello everyone, we are Team Descript. In this diverse world, if there's one thing that binds us all together, then it's social media. Currently, there are about 4.9 billion people using social media, and that accounts to up to 59.9% of the global population. With this increase in social media usage, there have been a sudden surge of cybercrimes that happen in our country. This may take place as phishing, identity theft, cyberstalking, etc. Due to all these reasons, we have selected our problem statement to be fake social media profile detection and reporting, and our problem statement code is SIH'2364.
Now let's look at the solution after we have understood the problem statement. The solution first is built on the Python code. The source code of the solution is open source. The solution has a lot of latent potential for later development. There are respective packages of each code present in the solution.
We have taken Instagram as an example and have traced down a Python script that compares the PFP of the real and the supposedly fake account, and even checks the suspicious account for bait keywords commonly used in a fake account and sometimes even accounts that have been hacked. Let us look at the code. The code uses installloader, numpy, OS, and OpenCV. Installloader package is a freely available package that has the functions required to fetch a detail from the specified Instagram account. We are talking about downloading profile photo and even checking post statistics such as like count, etc. The OpenCV package is used for image processing and is one of the most efficient packages out there when it comes to image processing. The code starts by defining two functions, checkFake and compareImages. The checkFake function takes in the bio of the suspicious account as main string and the preset keywords that are used in the fake accounts as a substring. If there is any keywords found, the function will print that the bio has suspicious keywords. Coming to the compareImages function, we are passing two PFPs. One is the original account's profile pic and the other is a fake account's profile pic. Then we are using the peak signal noise ratio algorithm to check and return the similarity score. Coming to the main part, we are creating an object of installloader and asking the usernames of the suspected account and the real account. Then we are fetching the details of the suspicious account with the input username and storing it under a structure named profile. Now, all details such as follower count, bio, etc. are in profile. Then, after printing the follower count, we check for the keywords in bio and we will be using the checkFake function. Next will be the profile pic comparison, where we will be downloading the profile picture of both the real and fake accounts and are storing it in a separate directory. We store the two images to two variables named image1 and image2 using OpenCV and pass them on to the compare images. Later, an output is generated based on the similarity score that was returned using the PSNR algorithm, and then the stored images are deleted after use. This is the complete demonstration of the code, and we can see that it generates a precise output. This is a part of what we have in store for the full project, since there are endless criteria that can be devised according to the trends, and we strongly believe this to be the next phase of fake social media detection.
Provided Python code checks for change in the Instagram profiles. It monitors bio changes, follower count, and engagement. If we have access to Instagram servers, we can check recent chat keywords, identify specific words for recent conversation, language detection, determines the language used in recent communications, account public status, checks if the account became public recently, login device change, alerts if there is a sudden change in the login devices, recent email ID change, detects recent change in the email associated with the username. As we know that many solutions are confidential, that means they are private and not meant for public knowledge. These confidential solutions require a dedicated team of developers to work on them. The team must keep the details secret and not allow any room for improvements or upgrades to be made publicly. This ensures that the solution remains secure and undisclosed. But our solution has various improvements, workflows, and ideas related to the problem of fake accounts. Our solution is an open source enhanced with deep learning and monitoring algorithms. These upgrades help identify and store information about fake accounts as they appear sporadically.
As mentioned previously, we can further add more criteria in order to improve the accuracy of the detection. Scam accounts often impersonate and use phishing tactics to deceive the individuals into revealing sensitive information. Staying vigilant and cautious while encountering unfamiliar online accounts or requests is crucial to avoid falling victim to these scams. Based on the scam trends, constant monitoring of types of scams and following machine learning algorithms to capture and implement their respective countermeasures. To enhance security and protect against potential data leaks on social media servers, it is essential to implement encryption protocols and regularly update security measures to mitigate vulnerabilities. We have faced a few showstoppers during the process of implementing the solution. The servers of these platforms must run the script live all the time so that it can constantly check for any suspicious activities during its usage. We have also faced a lot of issues during the configuration of the API tokens that were used in our solution. Their official documentations were poorly detailed, and we had to research a bit more on how to access these tokens. The scammers constantly develop new ways to attack the victim's social media account. To keep up with their new techniques of attack, we need to frequently find and apply new algorithms which can be used to detect these new attacking ways and suspicious activities. Another issue is that the action that is taken on these scam accounts will be done after a long period of time. These accounts are suspended long after the scams have been done.
Our target users are mainly crime branch and other investigative agencies, which are the organizations involved in online security and fraud prevention. Secondly, anyone who uses social media platforms and wants to verify the authenticity of the accounts can also use our app. So these are our target users.
In conclusion, our problem statement addresses the critical issue of fake social media profiles through a robust approach focused on data driven authenticity testing. Our project is not merely a technical undertaking, but a commitment to building a digital world defined by authenticity, trust, and security. We have outlined the problem statement, provided a clear solution, and detailed the working criteria, the effectiveness, potential improvements, and showstoppers. Our mission is clear to empower social media users and administrators alike in building a safer and more trustworthy online world. As we navigate the complexities of fake social media profiles, we are collectively contributing to the creation of a more transparent and resilient online community. Together, we embark on a journey towards a digital landscape defined by credibility, integrity, and security.